So what we see here is that it is really impractical to show that all six pairs of corresponding parts are congruent in order to prove that triangles are congruent. So what we're going to do today is we're actually going to combine three sections, 5.3, 5.5, and 5.6, into one podcast here. In fact, well, it'll actually be two podcasts, one today and one tomorrow. But just trying to break it down. These might get a little bit longer than our regular podcasts, but again, we're kind of combining a whole lot of ideas into one here. So apologize for the length that's probably going to happen here. So our shortcuts are this. Our first one is side, side, side. And side, side, side is pretty obvious because basically we have all three pairs of corresponding sides congruent. So here in this picture, we can clearly see that AD and CD are congruent, AB and CB are congruent, and BD is a reflexive side. It's congruent to itself. That's what we call that, reflexive property, when we say that something is congruent to itself. So sometimes we refer to that as a reflexive side. So yeah, all three pairs of corresponding sides are congruent. So by side, 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 that's one of our shortcuts. If I can just show that all three pairs of corresponding sides are congruent to another triangle's three sides, then yeah, those triangles have to be congruent. We don't have to know anything about the angles. Side angle side is not too difficult, but it's a little bit trickier because order starts to come into play. And for the rest of these, order is going to be important. With side, 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 it really doesn't matter because it's all the sides. Side angle side is exactly like it sounds. We have two sides and an included angle. Now, again, very important to note that the sides we get here are these two sides and these two sides. And the angle that's congruent is the angle that connects the two sides. It's not like angle ABD or angle ADB. It's not that. It's side angle side. In fact, you notice that the side angle side is in the order side angle side, with the angle being exactly between the sides. And that's exactly what's going on in our picture. The angle is between the sides. It must be. It cannot be like this, because here we have angle B up here and angle B up here. We do have to have two congruent sides and a pair of congruent angles, but no, the angle is not in the right spot, so it is not side angle side. Okay? This is side side angle. Side side angle does not work. All right? Our next one is called angle side angle. Now, this is very similar to side angle side in that, again, angle side angle, the side is between the two angles. So now we have two congruent angles. Okay? Two congruent angles and the side between them, the side that connects those two angles. And as long as all those corresponding parts are congruent, then the triangles are congruent. This would not be angle side angle on the bottom because we do have two angles, but to start with, they aren't corresponding angles. And here, okay, these two are corresponding angles, and the sides are corresponding. But this side over here is between the two angles. This side over here is not between the two angles. All right? So again, angle side angle has to be in the correct order. Next up is angle angle side, which again sounds exactly like it works. We have two angles and the side that is not between the two angles, corresponding side. And so again, we see we have one pair of congruent angles, a second pair of congruent angles, and a corresponding side that's congruent in the order of angle, angle, side. So angle, another angle, and a side not between the two angles. Corresponding side. Now, what hopefully is obvious to you at this point is that you must have a picture to do this. And with us working primarily off of big ideas, it's a little bit tricky. It means sometimes you're actually going to have a pencil and paper by your side and redraw the pictures that you see on Big Ideas so that you can mark them up and see what's going on, because that's super duper important. This isn't just something you just want to take note of in your head and say, okay, I'm going to remember where I'm going to mentally mark it up. No, you want to do that physically. Okay? It really makes a difference to see what's going on here. There is a fifth shortcut. The fifth shortcut applies only to right triangles. Okay? Only to right triangles. It's called hypotenuse leg. Now, you're saying, wait a minute, all the other shortcuts have 3 parts. Why does this one only have 2? Hypotenuse leg. Well, actually, it has 3 because it's a right triangle. It's actually right angle hypotenuse leg. So sometimes you'll see it abbreviated as HL. Sometimes you'll see it as RHL, just stands for right angle hypotenuse leg. So it still has 3 parts. Okay? But before we can use this, we must know that triangles are right triangles. So we're always looking for those perpendicular lines or other givens that tell us it's a right triangle. Then we have to know the hypotenuses are congruent, and then 1 pair of corresponding legs in those right triangles. We have all that, we can use HL. Now, technically HL, when I look at it, I'm looking at this here. Okay, technically HL is something we said that didn't work before, which was side-side angle. Side-side angle. Okay, why does it work now? Because it's a right angle. It works because it's a right angle. It only works when it's right angle. And we don't call it side-side angle, we call it hypotenuse leg, because that specifies that it's in a right triangle. All right, so we're going to practice this. And this is what we're going to basically be working on today, is we are going to be practicing identifying which shortcut, if any, can be used in a given situation. So what I'm going to do is I'm going to mark these up and then see what we can conclude based on that markup if we have congruent triangles. So I'm going to start with this. I've got this side congruent to this side. I've got this side congruent to this side, and I've got this angle congruent to this angle. Everything's given. Which shortcut do I have in this situation? Well, it's pretty obvious. I have 2 sides and an angle. The only choice I really have is side, angle, side. And are they in the right order? Yes. In each case, it's side, angle, side. The angle is between the 2 sides. The 2 sides make up the angle. So yes, side, angle, side would be the correct shortcut. And the triangle congruence statement is something we always want. And here we say triangle ABC is congruent to triangle XYZ. So this is an example of a side angle side shortcut. Same situation. I'm going to give you this angle C and angle Z are congruent. Angle B is congruent to angle Y. And XY is congruent to AB. Which shortcut do we have here? Well, we can break it down a little bit. I have 2 angles and a side. Since I know 2 angles and a side, it can't be side, side, side. It can't be side, angle, side. It can't be hypotenuse leg because I don't have a right angle. So this is either angle, side, angle, or angle, angle, side. How do I know the difference? Well, the side here, the corresponding sides, is not between my 2 angles. Okay? This is the area between the 2 angles. And again, my choices are angle, side, angle, or angle, angle, side at this point. But my side is not between the 2 angles, so that's not the correct one. This is angle, angle, side. And we have congruent triangles. Let's try again. Okay. A right angle here, right angle here, another angle here, another angle here, that there. Now, which shortcut do I have in this case? And if you said angle side angle, you're correct. Okay, why? Because we have two angles again. This angle with this angle down here with this angle right here. And the side is the side between the two angles. So that's angle side angle. Now I know some people probably saw that right angle and thought, oh, this is going to be hypotenuse leg. Not always. Right angle, it is a right triangle, but we don't have the facts for hypotenuse leg. We just have angle side angle. And that's okay. Sometimes right angles are just right angles. It doesn't necessarily mean we have to use hypotenuse leg. Let's try this one. I think you probably are ready. By the time I got done marking it, said, oh, that's an easy one. That's just side, side, side. Side, side, side is usually very obvious. None of the angles are being used, just the sides. How about this one? And again, we look at this and say, well, I've got two sides and an angle. But there's a little problem. We've got this side and this side. Okay, I've got this side and I've got this side. But the angle I have is not the angle that connects the two sides. Okay, that's a no. You don't have that. So this would be side, side angle. So this is no congruence because it's side, side angle. Side, side angle does not work as a shortcut. By the way, side, side angle does not work. Neither does angle, angle, angle. So two that don't work are side, side angle and angle, angle, angle. So this one is a no congruent situation because it's not the angle between the two sides. The angle is over here. It's offset. That doesn't help us. We do not have congruent triangles in that picture. All right. Now I'm going to give you one more. And this is going to be for your Ed puzzle question. So I'm going to give you something and you tell me, do I have congruent triangles and which shortcut? Okay? So there we go. Okay, some more examples here. The one thing you're going to notice right away for this one that's different is I have the segment AT here. I'm not going to mark it congruent because segment AT is always congruent to segment AT. I don't have to mark it congruent in the information I give you. You may assume it's congruent because of reflexive property. Now, if we're actually writing out a proof, you're going to have to state that in the proof. And we'll deal with that more later. Not so much today. You will want to mark it in when you're doing it on your own work, but when I'm marking in the facts I have now, we're just always going to work from the idea that that is a reflexive side. That side is always congruent to itself because it's a shared side. So let's start with this. CA congruent to BA, and these two angles are congruent. Do I have congruent triangles? The answer here is yes, absolutely, because we have this shared side. This is side, angle, side. Side, angle, side. And triangle CAT congruent to triangle BT. Okay? How about here? Do I have congruent triangles? Yes, absolutely. Which shortcut? Well, the easiest one we get, side, side, side. How about now? Yes, again, we have that reflexive side, so this is going to be angle, side, angle, because the side here is the side between the two congruent angles. I don't want blue. Okay? What if I said that this? Oops, that's not so nice. You actually try writing with a pen. What if I said AT bisects angle CTB and angle C is congruent to angle B? So I didn't mark it this time. This time I'm telling you in words. Well, now we have to kind of decide what that means. Well, angle C congruent to angle B, that's fairly obvious. We'll mark that in. And then AT bisects angle CTB. Where are my congruent angles? When you highlight it like that, it's really easy to see. These are my congruent angles. Okay? And we have our reflexive side. Do I have one of my shortcuts? Absolutely. Angle, angle, side. Angle, angle, side. Now I know there's somebody out there saying, well, but couldn't you just go angle, skip a side, skip an angle, side, angle? No. It doesn't work in that order. We can't skip two pieces. I can skip the one piece, the one side, to get to angle, angle, side, but I can't skip two pieces like that. So no, this is angle, angle, side. How about now? What do we see that's different in this picture? Well, the first thing we see that's different is that we have parallel lines indicated, AC and ZX. And we have parallel lines, we get all our special angle pairs back. Oh, back to chapter 3, here we go. Right, we've got a Z here, don't we? Which means these alternate interior angles have to be congruent. We also have a second Z going this way. Okay, there's our second Z. So I've got these alternate interior angles congruent. And we have vertical angles. So I've got 3 pairs of corresponding congruent angles. Do I have congruent triangles? The answer is no. Okay, angle, angle, angle is not a shortcut. To congruence. And let me show you why. Congruence means they're exactly the same size. And if you remember back to our dilation, to our transformations chapter in chapter 4, we did dilations. I kind of showed you this. I took a triangle or a different shape. I think it was a hexagon. But we'll do it with triangles here. And I cloned it. And then we did the dilation by reducing the size, right? But remember, I showed you that the corresponding angles were still exactly the same. Okay? All 3 pairs of angles are exactly the same, are exactly congruent. The angle pairs are. But clearly the triangles are not congruent because one is much larger than the other. That's why angle, angle, angle does not work. So my answer here is, even though I've got 3 pairs of corresponding angles congruent, those are not congruent triangles. How about now? And this is going to be our last ed puzzle question of the day. I do want you to notice that we no longer have the parallel lines. We do have something else going on here that we had in the previous question. So you tell me, what do you think the congruence is? All right, one more. Here we go. I think this is our last one of the day. Once again, I don't have parallel sides, but I do have my vertical angles. The picture gives me that. Then I have 1 pair of corresponding sides congruent right here and right here. And a 2nd pair of corresponding sides congruent here and here. Do I have congruent triangles? Again, the answer is no. Side-side angle does not work. And I'm sure by now you've probably noticed if you reverse the letters in side-side angle, you get a little bit naughty word. Okay, so if you see that naughty word forwards or backwards, that's not going to be one of our shortcuts. It doesn't work. All right, that's kind of a long podcast, but hopefully that really explains our different shortcuts. Just to summarize very quickly, our 5 shortcuts are side, 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 angle, side, angle, side, angle, 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 side, and right angle, hypotenuse, leg. Those are my 5 shortcuts. Those work.